Hi, today we are going to discuss about an important topic, AWS outage. You might have heard about this in all the places and Twitters and LinkedIn. People have been posting about this AWS outage. So on October 20, AWS outage has happened and many applications, they have experienced the downtime. And what exactly the things are happened? So what is the reason behind the stuff and how this can be articulated in a way so people can understand it in a better way, and what is the lesson learned from this? And this seems to be like a system design engineering concept, but it is not just for system design people. It is more than that. Already in top product based companies, they have started asking questions related to this AWS outage in their system design round and product interview round. And these rounds are not just for software engineers, it could be for data engineers, data analyst, ML engineer, AI engineer. So we should see what exactly happened and then what fix they have done and how this can be prevented. It's all like an educational purpose and all like you can have it in your mind as if you are a solution architect or if you are a system design architect, you can implement this in interviews and the interviewer will be very much impressed when you explain this. So before even we start this, right, I just wanted to show you the characters. So let's take this entire video as like a documentary, and this video will be lengthier for sure because I have explained each and every concept, a concept and sub concepts of it. So I just want you to understand clearly. I don't want to give some technical terms or the jargons which without having any clue of what exactly it is, right? So let's take this like a movie or a documentary kind of stuff. First, let's see the characters, which are all characters who involved in this AWS outage. The very first thing is I want to say something called DNS, and then the next thing is Route 53, and then regions, and then DynamoDB, and then DNS planner, and then DNS Enactor. Okay, so these are the characters of this movie. Okay, so first thing, what is exactly this DNS is? Okay, so domain name system is the full form of DNS, but what exactly this DNS is? So imagine that you buy your own domain, right? So I have my own domain, tablenotfound.com, where people can practice SQL in 4 different languages in a storytelling way. Like that, we have zomato.com, chatgpt.com, or chatgpt AI, or whatever the domain name. So the domain name is something, it's for human readable and human can easily able to remember, right, in their mind, in their brain, right? So what exactly the internet requires when you try something like www.tablenotfound.com or google.com, right? So when you just do this, okay, imagine like I go for tablenotfound.com and then in the internet and it goes to the server, right? So this is the internet. So when it goes to the server can understand only IP address. The server cannot understand the domain name. So what comes into picture is this DNS. So this DNS will receive this table not found, the domain name, and converts that to an IP address, for example, like this. That is what DNS. So imagine that in your phone you have a contact app, right? What is the use of the contact app, right? So you can able to remember the names, but not the numbers. So you save a phone number of your friend with his name or her name. And whenever you want to call them, you search for their name, but not the number. The same thing, right? Because your mobile networks accepts only the numbers, not the names. But your brain remembers only the names, but not the numbers. So that's what the domain name service is also all about. So we remember tablenotfound.com, but not my IP address, right? So DNS will convert that as an IP address and then sends it to the server. That is what a DNS does, right? Okay. So now next, Route 53. So Route 53, so DNS is a concept, okay? And the implementation for that we need a tech stack, right? In AWS, the DNS part is done by a tech stack called Route 53. Now imagine, so let's take an example, database. Database is a concept, but the implementation is a product. MySQL, Oracle, DB2, Postgres, right? So DB is a concept. To implement that, we have a tech stack like these databases. Similar to that, DNS is a concept. In AWS, to do implement that, they have Route 53. Okay, so Route 53 is the one which does this DNS part in AWS. Okay, right. See, AWS is one of the leading cloud provider, right? So imagine you buy a new house And for that house, you need all the accessories to be filled in, right? So you go for e-commerce website like Amazon and then you buy everything. Similar to that, you want to develop a new app, a web app or a mobile app, right? And for that, you need all the services and backends and front ends and the tech stack, right? AWS provides it for you. So let's get into AWS, Amazon Web Service, and you buy all the services whichever required to build your application. That's all. Right? So AWS is a place where we have lots of services, also called as microservices. You want to store something, yeah, we have DB. You want to do some AI, yes, AWS has a AI stuff. You want file system, they have file system. You want storage, they have databases and then disks, and then you want some resource like RAM, yeah, they have. You want CPU, they have. You want some visualization tools, yes, they have. Pay for what you eat, right? Fine. So regions, okay, what exactly regions is all about? Let's see, for you, the cloud is virtual, but for AWS, it is physical, right? They have to have the servers somewhere. They buy a land and they build a service for you, but for you, it is virtual. But for AWS, it is physical, right? So just see this image. So AWS regions means like in the world, the list of places where they have their own servers, the physical servers, right? So if you see in India, we have in Hyderabad, Mumbai, and then Australia, we have it in Melbourne and Sydney, and then we have it in London, Europe. So similar to that, there is one region called North Virginia, and the short form for this is we call it as US East 1. For every location, we call it as a region. We have a short form name like this. And one of the oldest region for AWS is this North Virginia. And in this region only we got the issue. And that's why AWS outages came into picture. Right. So now imagine each of this region is a physical location for the servers. Now if you are in India and your app works only inside India, right? And in that case, you can deploy your app in the region which is very near to your app. Like you are in India, then you can use Mumbai and Hyderabad, or you can use Singapore region, right? So that way you can host your app, all your data, all your services, everything will be stored and running in that particular region. Now imagine all your data is stored in Mumbai region. There are some disasters happening, right? Then you can go for multi-region concept where you can have all these app running on two regions. Like if one region is there any issue, you can go for another region. So still your app will be 24/7 up and running, even though if one region has an issue. But to enable multi-region, you have to pay accordingly, right? Now the thing is, there are some companies who raised an issue saying that I enabled multi-region, but still when North Virginia region went down, my app is also down, but I enabled multi-region. So this is some companies, they have raised it in as a concern in LinkedIn post and Twitter I could see. So what happened is AWS doesn't give any official statement, but then what were the rumors are, because that is well proven, right? So the rumors are AWS, even though they have multi-regions, okay, imagine they have a region Hyderabad in India. They have a hidden dependency on this North Virginia. So every region have a hidden dependency on North Virginia, they are saying. So that's why even when you enabled multi-region, when North Virginia was down, your app is also down, even though you have enabled multi-region. There is no official statement of confirming this from the AWS side. But then people who have multi-region enabled also got failed, means their application has also got faced this downtime. Right. The next thing is DynamoDB. So DynamoDB is a NoSQL database. Okay, so we have RDBMS SQL database and modern DB, we call it as NoSQL database, and all these NoSQL database works under a theorem called the CAP theorem, consistency, availability and partition tolerance. DynamoDB is very good in availability and it is very low latency. Low latency means the data that you fetch will be very faster. That means the response will be in milliseconds. So when I say milliseconds, it seems to be like very less, right? You are getting in very good short time period, but in companies, even milliseconds or like people will consider as a very big time. It should not be millisecond, it should be nanosecond. Right, in companies, people used to say, especially from the solution architect side and product side, they will say millisecond is still will cause a delay. Let's make it as a nanosecond, something like that. So millisecond is something okay for us, but for the companies and solution architects, even milliseconds causes delay. Right. So, but DynamoDB is like low latency, a millisecond response time you will get, and very good in read and write, and it is very good in availability. Okay. So we have highly available database. Fine. Now, what exactly the next two characters of this movie? DNS planner and DNS enactor. But before even getting into this, I want to tell you something. Okay. So let's take AWS. Okay. So AWS is a service provider, and what internally the AWS has is lots of microservices. Now let's take Zomato app, a food delivery app. Right. So in Zomato, you will be having lots of microservices like a service. See, as a Zomato is one service, but internally there will be lot of sub services called microservices. So imagine you place an order. So order is a service, and imagine you place a payment. So payment is a service. Imagine you add some food to the cart. So cart is a service. So managing all this as a one service is a huge burden for us. So we split this into microservices, right? And each of these microservices, it's from the application level. So in technical level, at the backend level, each of this will be, imagine entire Zomato food delivery app is hosted in AWS. Now, each of these microservices will use separate services in AWS. For example, imagine all the orders are happening and the storage all happening in RDS. RDS is a service in AWS called Relational Database Store, which is like an RDBMS in AWS. And all this payment processing is happening via EC2, Elastic Compute Cloud. EC2 is like a machine with the RAM and core and hard disk. It could be a Linux or Windows machine. And then you can run Python or Big Data Spark, whatever on top of it. It's like an empty machine. You do whatever you want, ETL processing. And then cart is happening in, again, like that happens in DynamoDB, just imagine, right? So now, this payment should be linked with order, right? So a payment is happening for the order that you have placed, what you added to the cart. So order is linked with the cart and order is linked with the payment, right? And that means internally the payment system which is running in EC2 need to connect with RDS to check that particular order has been added to the cart. And that means RDS needs to check with DynamoDB to see whether the particular item is added to the cart, and then the order is being placed and the payment is being done. So each of the services has to be get connected, right, internally. Right. So what exactly makes this connection possible inside AWS? So for all these services in AWS, there will be a name, a domain name. If you take RDS, there will be a domain name like US East 1.rds.amazon.com. This will be the domain name for RDS. But the thing is, if RDS wants to connect with EC2, EC2 will understand only the IP address of RDS but not the domain name. So this domain name is for you, for developer like us to understand. So here is where the DNS comes into picture. The Amazon's its own DNS, we call it as Route 53, which I told you already, right? So Route 53 is doing the DNS part in AWS, I said, right? So now this Route 53 is the one which converts this US East RDS Amazon.com to an IP address, for example, 10.2.1.7, something like that. That is done by this Route 53. Okay. Now, this is what the thing we should need to understand. See, the domain what we are seeing, Zomato.com, is also converted to an IP address in the internet world. It is done by DNS, but that is outside AWS. But even inside AWS, each services is connected with IP address only. And convert the domain to IP is taken care by Route 53. Okay, fine. Now, in AWS, so that's what. So I covered all this in the Zomato here. So AWS services, when all these services are connecting each other with this Route 53. Fine. So now let's come to this DNS planner and DNS enactor. Okay, let's go here. Okay. Now let's, okay, fine. Okay. So now comes DynamoDB. Okay. Why all of a sudden you are starting DynamoDB again? So previously I explained only the cap theorem, but I didn't explain what is the DynamoDB's part in the AWS outage. Okay. So what exactly happened is, See, we have so many services in AWS, right? So S3, EC2, EBS, Athena, EMR. We do have CloudWatch. So many services are there. So out of these services, like imagine we have 500 plus AWS services, out of which like some 100 plus AWS services use DynamoDB for storing the metadata information. For example, imagine that you are launching an EC2 instance. You are creating a virtual machine with Linux with 4 GB RAM, 1 GB hard disk. So you are creating a machine, a virtual empty machine, a Linux or Windows machine. It could be, we call it as EC2. So this EC2, so we have 7 steps to create an EC2 instance. In front end, in Amazon front end, we have it as 7 steps to create. But internally in back end, to create this EC2 from front end, it is 7 step. But in back end, we don't know what is happening, right? So how many steps in background it is happening for every one step? So totally 7 step. For every one step that you do in front end and back end, it will be like 10 or 20 steps will be happening, which we don't know, right? So when EC2 is getting created, there are like from front end itself, we have 7 steps. First step is to give a name of for the EC2 and then choose the RAM, core, and then key maker. And there are so many key part and so many steps are there. And each of the step has to be stored somewhere, right? Then only like the next step will know what happened in the previous step. And not just the front end 7 steps I'm talking about. In back end, for each and every step, there could be like 10 and 20 steps could have happened, and all this has to be get stored somewhere, right? So most of the AWS services use DynamoDB for this purpose because they are highly available and low latency, milliseconds. So that means for every service in AWS, for storing their metadata information, their state information, their logs information, all that in DynamoDB. They store it in DynamoDB. Okay, fine. So it comes to DynamoDB here. Okay, now how this thing, what you said, is related to this DNS planner and DNS enactor. I'll come to the point now. So now let's talk about what exactly these two characters are doing here. Okay, now imagine whenever there is a new IP comes into picture, that means whenever you create a new service, a DynamoDB service or EC2 or S3 or EBS or EMR, whenever you create a service, a new IP address comes into picture. Or you are deleting a service, then that IP should be get deleted. Or you are modifying you want to modify the domain name of the service, then an update is coming to the IP address, or time to live is there. So many things will happen in DNS. So this DNS planner, okay, will plan for it. Imagine you are creating a new EC2 instance or S3 storage you are creating now. So this DNS planner will plan it. So that means it will say like plan 1, a draft record came into picture. That means you are drafting a new domain name, and then plan 2, then you are updating a plan 2 like in progress, and then you are creating a plan 3 active, or you are creating a plan 4 for some other service, okay, for some other set of version, like empty, you are deleting it empty. So like that, this planner will create a plan of activities for each and every service that you create, that comes with IP and time to live and set of DNS concepts. Okay, now after this planner, there is something called DNS enactor, which will read this plan, the latest plan. It will read the latest plan, and then it will execute. Execute means it will make the changes. So DNS planner is input for a DNS enactor. When I say DNS enactor executes, what that mean? It will send this information to Route 53. Route 53 is the one which converts the domain name to an IP address, right? So this Route 53 will have all the DNS informations with the entry. So whenever S3 wants to communicate with EC2, right, it checks with Route 53, and Route 53 will give the IP address, and then S3 will connect to EC2, right? So now imagine the DNS entry is missing in Route 53. There is no entry for this EC2, which S3 is requesting for, but the EC2 is there, but the address is not found. The EC2 is there. Okay, the which EC2 machine you want to connect, the EC2 is there running virtually, but the address is not there. So this S3 will not able to connect with this EC2, and that's what happened. How come route 53 doesn't have the information of this EC2's IP address? Now let's go back. See, this DNS planner is like a friend 1. Okay, so this is friend 1. Okay, friend 1. And this is friend 2. And this friend 1 and friend 2, they are using Google Sheet, one Google Sheet. They are using it in parallel. Now imagine friend 1 making an entry in Google Sheet, still autosave has not happened. In shell 1, friend 1 is writing something. And when friend 2 comes to that same Google Sheet in his laptop, he didn't see anything on the shell 1. So he deletes the shell 1. But still the friend 1 is writing something. So whoever saved the sheet first will get saved. And the third user who opens the sheet, I could see the field is empty, but still friend 1 is keep on writing. Right? The overlap, timing overlap is happening. That means friend 1 and friend 2, they are not in sync. They don't have a dependency each other. That's the problem happened. And this problem has been there for a long time, but it was waiting for the perfect situation to occur, and the situation happened on October 20. Right. What happened is, so DNS created so many plans like this. Okay, what happened is, the plan 5, DNS planner was creating in plan 5, which is in a draft mode. Imagine something like the draft mode. It was writing it. And that time, this enactor came and it identifies this plan 4 empty is the latest one. And it picks the empty and then it sends to route 53. That means route 53 now has empty entries. There is no entry, an empty form of something, a DNS file. Now that means any request that comes to route 53 for asking for the IP address, it will respond back saying that I have nothing. Right? Now imagine a person has an amnesia. He can't able to remember anything more than 5 minutes. So he capture a picture of everyone who visit in his life. Right? And whenever that person comes to that guy, approaches that guy checks whether he has visited the person already or not by checking the photo, which he has already taken. But that photo is not there with him now. That is, that amnesia patient is route 53. Now route 53 not seeing any entries with him, and route 53 consider that request for the requested instance is not available. Route 53 will respond back saying that I don't find any service running with this IP because my DNS is empty. Right? All happened because of the culprits. These two people are the villains. DNS planner and DNS enactor. And we call this DNS planner and DNS enactor as a DNS automation process. And AWS said this automation process only some bug created. The bug is nothing but this empty record thing. And that's why DNS didn't get anything. There is nothing in the DNS, or router 53 also not able to serve the request. And some people used to say load balancer also a culprit, right? So you might have seen some blog, they have written load balancer is a culprit. So load balancer is again a service in AWS, right? It's again a service in AWS that checks the servers, server 1, server 2. It checks the server and receives the heartbeat. Heartbeat means the health status. And any request that comes to load balance will, what it will do, it will route the request to an appropriate free resource, to the free server. Now this again a service, as I told you in AWS, this is again a service. That means load balancer will also have a domain name. And any request that comes to load balancer, and load balancer has to connect to the server. Imagine it connects to some EBS server or Redshift server. Load balancer send a request to route 53 to get the Redshift IP address, and then route 53 will say to the load balancer, the requested domain name, I don't have any IP, but even though the Redshift server is running fine or the Athena server is running fine, but load balancer will say all the requested servers are dead. And this again makes the problem more worse, because load balancer starting giving negative response saying that all the servers which you are requesting is dead, but then it is not dead. Since the route 53 has an empty entry of DNS, any services like S3 to EC2 or EC2 to DynamoDB service level, service to service communication was not happened. Now, what is the fix they have done? So this is the culprit, this is the villain we have discussed. And what is the solution fix they have done is, the very first thing, they stopped this automation. The automation mean they stopped this planner and enactor process. They stopped it and they had the backup of this DNS entry in another system. They recovered it and they restored it. And after recovering it, what else the checks they have made, the fix they have to do, right? Which in future they should not have such problems, right? So what exactly the fix they have made after recovering it? See, in 5 to 6 hours, they made the fix. They recovered all the DNS and slowly things have been started working fine. But the fix what they have done is, one is, whenever an enactor see an empty entry in the DNS planner, it should not react. That's what the fix they made. That's what's the rule they have written. That's what AWS says. And they reduce the rollout time. Rollout means whenever the enactor sends the information to route 53, it immediately implements it all over the regions and all over the servers. So in a fraction of seconds is what they are saying. So they reduced it. They increased the time so that they will come to know the issues slowly one by one, and so that they can fix it immediately, even before the issues spread across all the region. They can identify it even before that when they increase the time of this rollout. And then they increase the monitoring and health state checks and alert emails and all those stuff. So that's what the prevention they have done. And this is what you have to say it in the interview as well, how this can be fixed or what fix they have made. And apart from this, one interesting fact I will tell you, you can add a chaos testing. So Netflix used to do this. What they will do, right? All of a sudden, one fine day, they will make their on-demand servers to down. They do this purposefully to see what errors are coming and how fast we are fixing it without even making any delay or any issues in the front end. Alright, so this is something recommended. So this is an interesting point that you can say in an interview where the interviewer can get impressed, right? So this kind of testing is very important. This chaos testing is very important. And you can make use of AI to find the anomaly, detect some anomaly and make an alerts. Even it is kind of false alert is fine. Something like we can check at least, right? So these are some prevention and how to prevent kind of steps which I wanted to tell you. So these are the application which faced this outage because of this AWS. You can see Canva, Reddit, Replit, Slack, Zoom. So many companies, Blink. So many companies have faced an outage, and there are some revenue losses also happen. So if you take AWS, their per hour revenue loss was 72 million. And Snap, it is $600K, and for Zoom, it is $532K. I'm talking about per hour, guys. And then Canva. So Canva has $342K dollars loss, and Slack 194K, and Reddit 148K. And does AWS provide refund for this? No, they won't provide refund, but they will provide credits in the next billing cycle. That's what AWS says. And that's all, guys. I hope you enjoyed this video. If you enjoyed it, just in the comment mention yes you enjoyed it or the video is really good. So that encourages me to make more such videos. And once again, thanks for watching, and please do subscribe my channel and follow this to friends and colleagues. And I do have a platform called Table Not Found, where you can practice SQL in a visualized way with pie charts, graphs, and you can practice at the same time you can learn. And I have a playground where you can drag and drop the SQL commands, and you can frame your SQL query and then you can execute it. And I have an ATS checker, AI based, and then AI based quiz, and soon I am going to launch PySpark and Python as well in my platform. And the very important thing about my platform is I support 4 languages: English, Tanglish, Tamil plus English, Hindi plus English, Tenglish, Telugu plus English. So each and every definition explanation will be in step by step on these 4 languages. Just go and explore the platform. Once again, thanks for watching, guys.